Hacking mobile platforms. In this lesson, we're going to begin talking about hacking mobile platforms. We're going to talk about threats that's targeting mobile platforms, the different type of attacks, countermeasures, and tools that you'll need to be aware of in hacking mobile device platforms. So let's go ahead and get started with this lesson. So, mobile platforms. Most mobile devices have internet based messaging, URLs, email, application downloading, and the list goes on. A lot of different applications that access the internet. Because they access the internet and these advancements in technologies, hackers continue to use them for malicious purposes, and it makes them an easy target as well. Now, as mobile phones grow and are now regularly used for any type of transactions, financial transactions, banking applications, work purposes, and the other diverse multitudes of uses, again, it makes them a strong target for attackers. So, mobiles contain important data such as contacts, messages, emails, could be business information, and other sensitive data. And these files can be easily stolen once a phone is compromised. Now, there's different types of attack vectors when you're attacking a mobile device or when an attacker is targeting a mobile device. Now, first, we're going to look at the OWASP top 10 of mobile threats. And again, we've went through OWASP platform before as far as their top 10 threats and attack vectors for mobile devices and other mediums and other classes. So let's do the same for mobile device. Let's see what the OWASP top 10 mobile threats are. So the first one we're going to look at is broken access control. And this is access control systems are intended, of course, to ensure that only legitimate users have access to functionality. But when this access control is broken or misconfigured, that allows the attacker to bypass access controls, and that fails to implement the principle of least privilege or some type of protection. So, and therefore, they can access that sensitive data we were just talking about. Cryptographic failures. These includes a failure to use encryption or a misconfiguration of encryption. Injection issues. Injection vulnerabilities are made possible by a failure to properly sanitize user input before the data processes it. Insecure design. Vulnerabilities can be introduced into the software during the development process. And again, this vulnerability is due to the design of the application. Security misconfigurations. The security of an application is also determined how it's configured. So basically, there could be some default configurations there. And if they're not applied or left at default status, that could be an open door for an attacker. Vulnerable or outdated components. Again, components used in the mobile device itself. They could be outdated. They could be have vulnerabilities in them. This is another door for attackers to exploit these vulnerabilities and attack the device. Identification and authentication failures. They occur when an application relies on weak authentication processes or fails to validate authentication information properly. Software and design integrity failures. Now, this vulnerability class includes relying on a third party code from untrusted sources or repositories and failing to secure access to this pipeline. Security logging and monitoring failure. Many security incidents are enabled or exacerbated by the fact that the application fails to log significant security events or log these files not properly monitored or handled. Server side request forgery. Vulnerabilities can exist when web applications do not properly validate a URL provided by a user or fetching a remote resource located at that URL. So, in this case, an attacker exploiting the vulnerability can use the vulnerable web application to send a request crafted by the attacker to the indicated URL. Redundant functionality. Attackers can review log and configuration files for mobile applications to look for redundant functionality that can be used to reach a back end. So, for instance, an attacker might use anonymity to carry out a privileged operations. Before release, manual code reviews can reduce this risk. Other attack vectors, smishing. Smishing is known as a phishing using an SMS messaging platform instead of a email or something like that. Smishing attacks, a natural progression from the phishing phenomenon, attempt to con mobile users by sending fictitious text messages with links to sites that look legitimate, but indeed they're fraudulent. And there's also targeted phishing attacks. A scammer may send an email to try to trick the mobile device user into clicking on a link or something along those lines to get to a malicious site. Apart from attacks, a mobile platform has several other vulnerabilities and risk. So, of course, there's mobile spam and phishing that we spoke about earlier. Spamming technique for a mobile platform is which unsolicited messages or emails are sent to the targets. So that's one attack or a threat a mobile device platform could have. Open Wi-Fi or Bluetooth networks. Again, open Wi-Fi means that you can use it at a coffee shop or McDonald's or any place like that. But however, by using that, you introduce and open that device up for attacks. It could be some type of Bluetooth network attack if you're in the vicinity of other Bluetooth devices. Blue bugging, blue snarfing, and packet sniffing are common attacks on open wireless Bluetooth networks, but there's other attacks that can happen on the 802.11 network for unencrypted Wi-Fi and open Wi-Fi areas. We talked about the threats. We talked about vulnerabilities. Now, let's talk about application sandboxing. So basically, sandboxing is a protection tool that enables the isolation and protection of the system resources and other applications from malware and other threats. It's also known as application containerization. So developers can separate each application into its little virtual machine or wrap their applications in a security policy to shield them from these effects. Now, enhances the security by restricting the environments in which specific code can run. And also, of course, it has significant security advantages. And software companies like Apple, Google utilized it to provide users with a safe application environment. Now, there are some issues with this. Advanced malicious applications may be designed to bypass the sandboxing technology, or fragmented code and sleep timer scripts are common techniques attackers adopt to bypass this inspection process. Now, application sandbox with user level validation. This type of sandboxing, they produce system calls to the operating system and how an application and its environment interact. This includes changing permissions and accessing the network on device and files. Now, users can create policies in the sandbox that specify what system calls are allowed. Now, on the Android sandbox, the Linux user base protection is used by the Android platform to identify and isolate app resources. Now, apps and the system are shielded from malicious apps by this isolation. Some of the features of this include has kernel level sandbox for each Android application, and it signs it by using a unique ID. This kernel ensures that security between apps in the system are at the process level. Uses app assigned user and group IDs to provide Linux based protection for the app resources. Because they lack the necessary default user privileges, apps in the sandbox cannot commit malicious actions against other apps. So that's the Android sandbox. Now, application sandboxing with OS support integrated. So the Windows Sandbox. Windows Sandbox allows users to run applications and code in a secure and lightweight environment. So when the sandbox is closed, all software state and files are deleted, making the environment only temporary. A new sandbox is created when the sandbox application is run again. Now, let's jump to the Apple sandbox. Apple also offers a user level library function sandbox at the kernel level. But unlike the Linux sandbox that we mentioned earlier, it does not use a BPF filter. The Apple Sandbox has a server level process for handling kernel logging and kernel extension for using a trusted BSD application, program interface, or an API. And there's also a Java sandbox, also called the Java Virtual Machine. This is a fictitious architecture in which the application developer is unaware of the client's operating system or hardware architecture. The bytecode verifier ensures that the code does not attempt to illegally convert data, circumvent array bounds, or forge pointers. Instead, it makes sure that the code looks like Java bytecode. Okay, we started off this lesson talking about hacking mobile platforms. We learned a little about the mobile platform attack vectors, also mobile threats, and spend a lot of time about application sandboxing. That's it for this lesson, and I will see you in the next lesson.